In February 2024, astronomers detected something that immediately stood out from everything we thought we knew about comets and asteroids. They named it 3IATLAS. The 3I part means it is only the third interstellar object humanity has ever confirmed, after the mysterious elongated ʻOumuamua in 2017 and the icy comet 2I Borisov in 2019. But here's where things get strange. Oumuamua was visible for just a few weeks before it slipped away, and Borisov only stayed in our sights for a few months. These brief encounters gave scientists almost no time to study them in detail. 3IATLAS is different. It has remained visible for more than a year and a half, an unusually long window that has allowed astronomers to track its every move. Over this extended period, it hasn't behaved like a typical comet at all. Instead of fading quickly, it continues to grow brighter as it approaches the Sun, breaking the usual rules of what interstellar visitors are supposed to do. Serious amateur astronomers with good equipment are now able to spot it for themselves, which is something unheard of for an object traveling from beyond our solar system. This long-lasting visibility and increasing brightness gives scientists an unprecedented chance to observe and gather data. And with every new observation, the mystery around 3IATLAS only deepens, setting it apart as one of the strangest cosmic visitors in recorded history. One of the most baffling things about 3IATLAS is the path it's taking through our solar system. When it first entered, astronomers were stunned to see that it came in at almost a perfect right angle to the flat plane where all our planets orbit. Normally, interstellar objects cross through at random angles, zipping by quickly before vanishing back into the dark. But 3IATLAS isn't just passing through, it's following a path that looks almost too perfect. In July 2025, it made a remarkably close pass by Mars, coming within just 22 million kilometers of the red planet. That's close enough that any spacecraft orbiting Mars could have captured detailed images if NASA had chosen to redirect them. Now its path is taking it toward Jupiter, where in November it will swing past the largest planet in our solar system at about 127 million kilometers away. The odds of an interstellar object randomly making close approaches to not one but two major planets in a single visit are incredibly small. Astronomers estimate less than a 1 in 500 chance. Add to that the fact that these encounters seem to happen at the most convenient times for Earth-based observers. Mars at opposition in July and Jupiter at opposition this November. And the trajectory begins to look less like chance and more like design. It's almost as if 3IATLAS is deliberately positioning itself for maximum visibility. For a supposedly natural space rock, that level of precision is deeply suspicious, raising the question, is this path just cosmic coincidence? Or are we witnessing something far more intentional? Before we dive in, hit that subscribe button and turn on notifications. You don't want to miss any updates on the universe's deepest secrets. And if you love exploring hidden mysteries and unexplained discoveries, give this video a like so we know to keep uncovering them. If the path of 3IATLAS wasn't strange enough, its size pushes it into the realm of the impossible. When astronomers calculated how big this object actually is, they came up with a number that stunned the scientific community, about 46 kilometers across. To put that in perspective, if you placed it over New York City, it would stretch far beyond Manhattan, Brooklyn, and Queens combined. For a visitor from interstellar space, that is enormous. Compare that to the other two interstellar objects we've seen before. Oumuamua was only about 200 meters long, barely the size of a skyscraper. 2I Borisov, which behaved more like a traditional comet, was less than 1 kilometer across. That makes 3IATLAS roughly 1 million times more massive than either of its predecessors. And here's where the real problem begins. Probability models suggest that interstellar space shouldn't contain large objects like this in detectable numbers. If a 46-kilometer wide body really formed naturally and drifted between stars, We should have already detected thousands of smaller ones first. Finding something this big before finding a proper population of smaller objects is like casting a fishing line into the ocean and catching a whale. On your very first try, even Harvard, astronomer Avi Loeb ran the numbers and concluded that there simply isn't enough material floating between stars to explain something of this scale showing up at random. In other words, the math doesn't work. Either our models of how the galaxy is structured are completely wrong, or 3IATLAS is not the natural object we're being told it is. The chemical fingerprint of 3IATLAS may be the biggest clue that something extraordinary is going on. In mid-2025, NASA's brand new SphereX telescope, which specializes in scanning the sky for chemical signatures, took a closer look at this interstellar traveler. What it found shocked researchers. The telescope detected massive amounts of carbon dioxide pouring out of the object, about 70 kilograms every single second. That's the equivalent of a car's worth of dry ice vaporizing into space every heartbeat. But here's the problem. Alongside all that carbon dioxide, SphereX saw no trace of water vapor and no carbon monoxide either. That is completely wrong for a comet. Every comet we've ever studied in our own solar system releases water vapor as soon as it gets anywhere near the sun's warmth. It's the frozen water inside them sublimating into gas that creates the spectacular tails we see from Earth. Carbon monoxide is also commonly present in measurable amounts. For 3IATLAS, the absence of both makes its chemistry unlike anything we've ever observed. Some scientists tried to suggest that maybe this interstellar object formed in an exotic region around another star, where water ice wasn't available. But that explanation doesn't hold up well because water is one of the most abundant molecules in the universe. For something to spew carbon dioxide at such massive rates while showing no water at all suggests one of two possibilities. Either this is a completely unknown type of object that rewrites our models of planetary formation, or it's something deliberately engineered with a very different composition than nature would ever create. As if the strange chemistry of 3IATLAS wasn't unsettling enough, things became even more mysterious when scientists analyzed the isotopes inside that carbon dioxide. Isotopes are like atomic fingerprints, subtle variations in the number of neutrons that reveal where an element was formed. By studying isotopic ratios, astronomers can usually tell whether a material came from the inner solar system, the icy outer reaches, or even from another star system entirely. But when researchers measured the carbon and oxygen isotopes being released from 3IATLAS, the results didn't line up with anything we've ever seen. The ratios don't match comets from our own solar system, they don't match interstellar clouds, and they don't even match the isotope patterns we expect from other stars. In fact, the chemical accent of this object seems to come from nowhere we know. This leaves scientists with two very uncomfortable options. Either 3IATLAS originated in a type of environment we've never discovered before, something outside the catalogue of known cosmic chemistry, or the isotopes have been altered through artificial processing. In other words, they could be the byproduct of manufacturing or deliberate engineering. It's a controversial idea, but isotopic anomalies are often the first red flag when investigating whether a material has a natural or artificial origin. And right now, 3IATLAS is waving that red flag higher and brighter than anything else in the sky. For any normal comet, heavy outgassing automatically means one thing: a dust cloud. As frozen material heats up and erupts into space, it carries tiny particles of rock and ice with it, forming the glowing halo and sweeping tail that make comets so spectacular. But with 3IATLAS, that's not what astronomers are seeing at all. Even though it's releasing massive amounts of carbon dioxide, there is no thick dust coma, no brilliant tail streaming behind it. Instead, what little glow it does produce behaves in a way that seems unnatural. Observations show material collecting in front of the object, as if it's being pushed or projected forward, rather than trailing behind, the way physics says it should. This baffling geometry makes no sense for a natural comet. The solar wind and radiation pressure always push dust and gas away from the sun, creating tails that stream in predictable directions. For 3IATLAS to display a glow ahead of its path suggests forces we don't yet understand, or perhaps a technology actively shaping its emissions. Some astronomers have even compared its appearance to a vehicle with headlights on, illuminating the space ahead of it instead of leaving a trail behind. That's how starkly different it looks compared to any natural body we've studied. And the longer 3IATLAS stays visible, the clearer this anomaly becomes, adding yet another layer of suspicion to an already impossible visitor. Perhaps the strangest clue about 3IATLAS isn't just what it's emitting, but how it's emitting it. Normally, when a comet releases gas, it happens because the sun's heat warms up the frozen surface. The ice sublimates, turning directly into vapor, and the temperature of the released molecules reflects that process. It's simple thermal physics, but with 3IATLAS the numbers don't add up. The carbon dioxide pouring out of it doesn't show the temperatures expected from solar heating. Instead, the molecules appear much hotter in some cases and much colder in others, completely out of sync with what sunlight alone could produce. Astronomers describe this as non-thermal emission, and it's a major red flag. Non-thermal outgassing means something other than sunlight is driving the release. That could mean chemical reactions taking place below the surface, mechanical venting like geysers, or, more provocatively, some kind of artificial system actively ejecting gas. The consistency of the CO2 jets and the sheer amount being released every second makes it look less like random venting and more like a controlled process. If that's the case, then 3IATLAS isn't just an oversized comet. It may be operating with an internal energy source, one powerful enough to regulate or even propel itself. And that possibility changes everything about how we view this mysterious interstellar visitor. Amid all these anomalies, one factor has captured the attention of astronomers and space enthusiasts alike: the silence from NASA. On August 6, 2025, the James Webb Space Telescope, the most advanced and powerful telescope humanity has ever built, focused on 3IATLAS for over 4 hours. This was not a routine observation, it was unusually long, using multiple instruments at once to capture chemical compositions, thermal readings, and even the potential presence of artificial materials. Normally, data from James Webb is processed and released within days or weeks, so that the global scientific community can study and verify the findings. But in this case, weeks have passed and not a single official update has been shared. That unprecedented delay has fueled speculation. Some believe the results are so complex or significant that NASA is taking extra time to verify them. Others wonder if the findings might point to something extraordinary, like artificial construction or evidence of extraterrestrial technology. The combination of a high-priority target and complete silence is unusual by any standard. James Webb is designed to uncover the universe's deepest secrets, and it doesn't waste observation time. For 3IATLAS to receive such focused attention and for the world to hear nothing suggests there may be discoveries that could challenge everything we thought we knew about the cosmos. This silence has made 3IATLAS not just a scientific mystery, but also a source of growing public intrigue, as everyone waits to learn whether we're looking at a natural anomaly or something far stranger. The clock is ticking for scientists and astronomers who want to study 3IATLAS up close. Its closest approach to Earth is coming on October 12, 2025, when it will be about 265 million kilometers away. While that may sound distant, it will appear significantly brighter than it does now, giving telescopes around the world the best chance yet to gather detailed data. Observatories have already reserved time, and several space agencies are reportedly considering redirecting spacecraft to capture closer observations. After that, 3IATLAS will make its closest pass to the Sun, known as perihelion, on January 3, 2026. Even at this point, it will remain farther from the Sun than Earth's orbit. which means it won't undergo the extreme heating that typically drives dramatic changes in comet behavior. From there, it will begin its journey back toward the outer solar system and eventually vanish into interstellar space, likely becoming too faint to observe sometime in late 2026 or early 2027. This narrow window makes the next few months critical. Ground-based radar facilities are preparing to attempt detection to measure its exact size, shape, rotation, and surface properties. Spacecraft like the Juno probe orbiting Jupiter could also potentially be repurposed to study the object during its November approach to the giant planet. Every observation taken during these encounters could hold the key to determining whether 3IATLAS is a natural anomaly or something far more extraordinary. Time is short, and once it leaves our reach, the opportunity to study this interstellar visitor in such detail may be gone forever. The final and perhaps most staggering aspect of 3IATLAS is what it could mean for science and humanity. Every anomaly we've discussed, from its impossible trajectory and enormous size to its strange emissions, isotope ratios, and lack of dust, adds up to something that defies all known natural laws. If 3IATLAS is indeed a natural object, then our entire understanding of comets, interstellar material, and planetary formation needs a complete rewrite. Textbooks, models, and theories that have guided astronomers for decades would suddenly be outdated. On the other hand, if these anomalies point to artificial origin, the implications are even more profound. We could be looking at a probe, a modified asteroid, or some form of technology sent intentionally from an advanced extraterrestrial civilization. The fact that it follows a carefully aligned trajectory appears to control its outgassing and exhibits chemical and isotopic signatures unlike anything we know, suggests that the possibility of intelligence behind it can no longer be ignored. In the coming months, as 3IATLAS approaches its closest points to Earth and the Sun, scientists have a fleeting chance to collect the data needed to answer these questions. Every observation could push us closer to understanding whether we're witnessing a natural cosmic anomaly or evidence that humanity is not alone in the universe. Either way, 3IATLAS is already rewriting the rules of astronomy and challenging us to rethink our place in the cosmos. This is a discovery that could change everything we thought we knew about the universe.